In this video, we'll see what RC phase shift oscillators are and how they work. We will also take a look at a TwinT oscillator, which is a special type of RC oscillator. This is the circuit of a phase shift RC oscillator. It consists of an op-amp and an RC network. Remember, due to the Barkhausen criterion, we require minus A beta of omega not equal to 1, where A is the forward gain and beta is the feedback factor. Here R2 and R1 form the feed-forward network. The RC network forms the feedback network. We need to find the beta of this feedback network. That means we need to find a relation between Vout and Vx. Writing a KCL at V1, we get V1 minus Vx upon 1 by j omega c plus V1 minus V2 upon 1 by j omega c plus V1 upon R equals 0. Writing a KCL at V2, we get V2 minus V1 upon 1 by j omega c plus V2 upon R plus V2 minus V out upon 1 by j omega c equals 0. Writing a KCL at node V out, we get V out minus V2 upon 1 by j omega c plus V out by R equals 0. Solving these equations simultaneously, we get minus beta, which is Vx by V out as 1 plus 6 by j omega cr minus 5 by omega square c square r square minus 1 by j omega cube c cube r cube. The gain A is minus R2 by R1. We multiply these to get the loop gain. Now we apply Barkhausen's criterion. We want a total phase shift of 0 degrees, which is the same as 360 degrees. The gain A provides 180 degrees of phase shift as it is an inverting amplifier. Hence, the feedback network needs to provide an additional 180 degrees phase shift. That means the phase of minus beta should be 180. Hence, the imaginary part needs to be 0. That means 6 by omega cr minus 1 by omega cube c cube r cube equals 0. This gives omega as 1 by root 6 rc. Now, we want the magnitude of the loop gain to be 1. Substituting this value of omega in the loop gain equation, we get minus A beta as R2 by R1 into 1 by 29. Hence, we need to choose R2 by R1 equal to 29. Thus we can control the frequency of oscillations by choosing an appropriate value of resistors and capacitors. One thing to note here is, unlike the VN bridge oscillator, we are not taking the output from the output of the op-amp. The output of the op-amp is fed back to the input via the RC network, and we get our desired sinusoidal output at the input of the op-amp. In this circuit, there are 3 capacitors and 3 resistors. Suppose it is built using N resistors and N capacitors. The angular frequency of oscillation will be 1 by root 2 N into RC. Now we'll see what a TwinT oscillator is. It is a special RC oscillator. It is called so because we have 2 twin RC networks in the circuit. R3 and R4 provide positive feedback and the TwinT network provides an infinite impedance at a particular frequency, called a notch frequency, and we obtain sustained oscillations at this frequency. If R1 equals 2R2 and C2 is equal to 2C1, we have F0 as 1 by 2 pi R1C1. The TwinT oscillator is suitable only for fixed frequency operations. Since the variation in its frequency requires variation in several components, it is impractical to use it in continuous tuning applications. That's all for this video. If you have any doubts, do ask in the comments section below. Don't forget to like, share and subscribe.